Hello friends, Jai Shri Krishna to all of you. Today we are going to see what is the difference between Waterfall, Basic Agile and Scaled Agile. So let's come to the Waterfall first. Waterfall is the oldest method of project management. What does happen in this waterfall? In this waterfall, basically we are just trying to efficiently manage the resources, and the way to do it is people say that everything in a project happens stage by stage. Means first of all there will be a requirement gathering phase. At that time it is not required for the developers to be onboarded. We can save the budget on the developers. Again, at that time testers are not required, so we can save the budget on QA resources, that is quality assurance resources, also called as testing resources. This way, in this method, the project development happens stage by stage and people are hired only for the stage. For example, this waterfall starts with the first stage, which is called as the requirement gathering phase. In this phase only the business people are hired. That means in today's world, if you call them, then they are called as product owners, business owners. Then under them there are SMEs, subject matter experts. Under them there are business analysts. These are today's terminologies. In those days they were just called as business people. So you hire them in the requirement gathering phase and they create a functional specification document. After that, they are released from the project, they go back to the practice, that means the business unit, and they can be hired for some other project. Then the next stage starts, wherein the architect is hired. Architect is the development architect who will decide the structure of the project. Structure of the project is also called as architecture of the project. Means how will the database layer be? Means which kind of database do you want to use, SQL or Oracle or nowadays MongoDB, that kind of database. So which database do you want to use? Then what kind of tables your database will be having, what will be their mutual relationship. Means there is one primary key, there is a foreign key in every table. Most of the tables have the foreign key, standalone tables don't have it. So which tables which will have which kind of keys, means which kind of relationships with each other, that will be decided. Point number one. Point number two, what kind of intermediate layer will be there between the database and your coding layer. Coding layer means where you actually write your code. See, coding people, developers, write code in terms of classes. They don't directly speak to a database nowadays in the modern world. Earlier time, yes, we used to have direct communication with a database. Now we don't do it because we have come to think that developers can think better in terms of classes instead of in terms of tables. So there is an intermediate layer in between the database and the service layer. That means whatever web services you write or whichever service layer you write, means whichever backend code, means Java or .NET code that you write, in between that and the database there's some intermediate layer. And that intermediate layer can be either, if you're in the .NET environment, then it is called as Entity Framework, and if you're in the Java environment, then it is called as Hibernate. So which of the two intermediate layers you're going to use? That is point number two. Then point number three, service layer. Service layer can be written either in .NET or in Java, or nowadays it can also be written in JavaScript. So like for example Node.js, that is a JavaScript backend layer. Now which technology will you use? Then which kind of a service you're going to write. For example, if you're using .NET, then it will be a .NET web service. Even this web service can be of HTTP type, or SOAP protocol can be used. Then what kind of contracts do you want to use? That means do you want to use JSON as the contract, or you want to use XML as the contract? This kind of things. This kind of decision formulates that how will your service layer be, and that is called as point number three. That is, how do you decide what kind of service you're going to use. Point number four is what kind of a UI layer you're going to use. So UI layer means it's the user interface. UI, user interface, that means it's the layer which actually speaks to the user. User is able to use this mouse or this keyboard to access your web application, let us say. So whatever the user sees in the browser, that is called as the UI layer, that is user interface layer. How will that be? What will be the basic structure? That means if you are writing in Angular, then what will be the controllers that you'll be using? Nowadays in Angular 2, you'll be saying that what will be the various pages that you'll be using. See, sometimes nowadays we have a single page architecture. In the earlier days, there were different pages and you used to navigate from one page to another. So, what kind of an architecture will you prefer? Single page architecture or multi-page architecture? Then let us say single page. Then single page, okay, what kind of technology do you want to use? You want to use Angular? You want to use React? What kind of technology? Then is it just going to be a UI? Just going to be a web application, or you also want it to be a hybrid application which can be used on the mobile as well? Then if that is the case, then maybe do you want to use something like Angular or something like React Native, that kind of things. So that will be your point number 4. All these decisions will be made by the architect, and that architect will make a document called as technical specification document. He'll write everything inside it. He'll be saying that, okay, this is the database I'm going to use, this is the intermediate layer I'm going to use, this is the kind of service I'm going to use, and this is the UI layer that we are going to use. And he'll just document it in one document which is called as technical specification document. Once that is done, now architect is released to the platform, to the practice, that means to your business unit. He can be hired by any other project now, and you hire the developers. So you go from design stage to development stage. Okay, now in the development stage, you don't have the business people, you don't have the architect, you only have the development team. Development team only refers to this technical specification document that your architect has created, and they start development. Okay, now during the development, they are not even tracked that, okay, what is your status, show it to me periodically, show something running to me. No. At max, they will be asked, okay, what is your status, you tell me, how much code have you written, that's all. But actual code, working code, there is no requirement that the developer should be showing that working code to the customer or to anybody. Okay, and that is how that development stage happens. Let us say the development stage is for, let us say, 6 months or 1 year. Then for 1 year, the developers are not even asked to show a working software. They might be asked for the status, okay, where are you, you tell me, and the developer can just say that, okay, I made the database, that's it, I made the intermediate layer, I made the service. But they are not vertically slicing it. They are not saying that, I have made a working piece of code which has all the 4 layers. No, that approach is not there. The developer can say for the first 2 months, okay, I only made the database, and for the next 2 months he can say that, okay, now I'm making the intermediate layer, means I'm just configuring the intermediate layer. Then he can say that, okay, now I'm making the service. It doesn't make sense actually, because unless all the parts of your product work together, the product is not workable. It's like the developer can say, if I am to make a car, I'll just be making the tires for first month, I'll just be making the wheels for the second month, I'll just be making the chassis for the next month, and it doesn't make sense to me. So unless all the parts of the car are made and assembled, that car is useless to me. I cannot make use of that product. And this is how the development happens in Waterfall. Then when the development is done, the entire development team is released except 1 or 2 good developers. Okay, and then the product goes into testing stage. Here once again, the QA people are hired. QA people are non-technical, means in the earlier days they were non-technical people. At max, if they were automation QAs, then they knew something about automation testing, but they did not know about the technology on which this product was based. Like if this was an Angular product, at that time Angular was not there, so wrong example. I should probably be taking the example of Java or .NET. So if Java and .NET was used for making this product, then the testers have no idea about Java or .NET. They only know about Selenium, let us say, which is an automation test framework. They don't know anything about the technology on which this product was based. Okay, and that is the testing stage. They find out all the defects that the product might have, and then those defects are fixed by the 1 or 2 developers that we have retained in the project. Okay, that is called as a testing stage. After that, there is a delivery stage. Now, in the delivery stage, this product is deployed on some web server. Let us say I'm saying that this product is a web application. So in that case, this web application will be deployed on some web server. Web server can be of various types, like if you're in the Microsoft environment, then it is like IIS, Internet Information Services. Then if you're not in the or maybe even if you're in the Microsoft environment, still most people still prefer Apache. So Apache web server can be used. If you're in the IBM, then IBM has WebSphere. So any kind of a web server can be used to deploy your web application. Deployment means that web application will now be running on this particular web server, and then it can be accessed from anywhere in the world using a web browser like Chrome or IE. Okay, so that is called as deployment. That means you put your code onto a web server where it can be accessed from any of the browsers, okay, from all over the world. That is the deployment stage. So that is called as the delivery stage of Waterfall. So in this delivery stage, what we are doing is we are making this product live for the people. Now during the delivery stage also, the customers can give some feedback. That feedback is received. 1 or 2 developers are still retained, 1 or 2 testers are still retained, and those testers or developers, testers will see whether that defect is valid or not, and they'll assign it to the development team will fix it. So only 1 or 2 QAs or 1 or 2 developers are retained till the delivery stage. Now this is how the waterfall model works. Now in this waterfall model, what are the downfalls? What are the problems? The problem with this model is that once you are in a particular stage, only the people required in those stage are there on your team. The people from the earlier stage, you have already released them to the practice or BU, okay, so they do not belong to your project. For example, if you are in the development stage, your architect is already released, he is working now in some other team, in some other project, so you cannot expect him to be very receptive to your queries. Let us say the development team did not understand what is written in the technical specification document, then the development team might find a difficulty in approaching him. Then the architect might probably he might even leave the company. Once you release him from the project, there is no guarantee that the person is going to stay in the company. He may get allocated to some other on-site opportunity. He might be 7 seas apart from you, and it's difficult to communicate after you release a person from a project. So that is difficulty number 1, that only those people are there on your team who are working on that particular stage, and that leads to a lot of miscommunication or lack of communication. Second problem is that there is no feedback taken. As I told you, the development team won't be asked to show a working model of code. So let us say the development team works for an entire year to develop the product, and then the testing team tests it well, and then it is delivered, and at the time of delivery the business people, or let us say the customer, sees the delivery and they say, oh my god, I wanted an elephant and you gave me a buffalo. So yeah, both of them are big, both of them are black, but these are 2 different animals. So I wanted an elephant, you gave me a buffalo. And it often happened in the waterfall model, because everything that the customer wants in a project is written or documented in functional specification document. So it is only written in words. Words can always be comprehended in different ways. And there are so many, the more intelligent people you have in your team, the more diverse ways they'll think of anything. And the difficulty is with the intelligence, to be honest. In IT, difficulty is with having more intelligent people. So they'll always comprehend in n different ways, and always it does happen that you wanted something and you get something different. So that is difficulty number 2, that customer feedback is not taken until the end. And many a times it happens that at the end the customer thinks, no, this is not what I wanted. And then what the customer says is, see, you either failed in taking my requirements, or you failed in development, or you failed in test. I don't know where you failed, but this is not what I wanted. And if this is not what I wanted, I'm not going to pay for it. So you keep negotiating the contract. The customer says that this is not good, I'm not going to pay for this. And if the customer is not going to pay for it, the contract gets negotiated. When does it get negotiated? At the end, when the product is ready with you. You've already invested everything into it. You give the salaries to so many developers, so many QAs, your architect, your business people. At the end, the customer says, no, I'm not going to pay you. So that is contract negotiation right at the end, and that is really bad for the business. Both the parties suffer. The customer also suffers, and the service provider. Let us say you're from Cognizant, or you're from CTS, or you're from TCS, or you're from Infosys. All these are service providers. They actually create the software for the customer. Now these companies also suffer, and your customer also suffers, because whenever there is a contract negotiation, both the parties suffer. Always remember this. So that is point number 2, that customer feedback is taken right at the end, and many times the product is not as per the customer feedback. And then point number 3 is there is no way to track whether at the low level where the team is. You do not know until the delivery whether the delivery is going to happen on time or not. You just don't know much about it. Let us say even within a stage, let us say in the development stage, the time given for the development is let us say 1 year. So in that year, how will you judge whether the team is on track? So you will have to rely upon the team lead's capability to guess whether the team is on track or not. And there's no guarantee. And let us say your team lead also switches the project, or he resigns or something, then it is a whole lot of mess for you. So it is difficult to track where the project stands at any given particular time. That is point number 3. You cannot track it. So I'll summarize the 3 points for you. Number 1, in every stage you have only those people who are assigned to that particular stage. So people from the earlier stages are not there for you to take help or reference from. Okay. Point number 2, you cannot many a times until the end of the project, you don't know what kind of a project, what kind of a product you're going to get. And when the customer sees it at the end, many a times it happens that the customer doesn't like that product, and that's why it does get rejected. There's a contract negotiation happening at the end, which is bad for both parties. Point number 3 is that you cannot track the project at any given time. Let us say you're 1 month into the project, 1 month down the project, you don't know where it is. You must just be thinking that, okay, the business people are making this document, okay, they have written 10 pages, but it doesn't make any sense. You need to have a robust mechanism to know how much is the progress of your project, and that cannot be done in any of the stages. I gave you an example of development as well. I just gave an example of requirement gathering. In any of these stages, basically, you just don't have a robust mechanism to find out what is the status. Where is your project at the moment? What is the status? Where do you stand? You don't have an access. Now, that is about waterfalls. These are all the weaknesses of waterfall. Waterfall used to be practiced when I started my IT career in 2008. At that time, yes, my first project was a waterfall model. But even that quickly switched over to something called Agile. Agile was said to be something which is revolutionary, something which has revolutionized the world. Now, what is that Agile? Let me give you an idea. In Agile, what people say is, we don't want all those weaknesses of waterfall. So that is why I explained those weaknesses in detail. Now, Agile has come from the ashes of Waterfall. So whatever is Waterfall, whatever are the weaknesses in Waterfall, Agile wants to overcome them. How does Agile do that? Yeah, in Agile, what happens is they want continuous feedback from the customer. Point number one. Point number two, in Agile, what they want is, you are not going to show me documentation. You are not going to show me words that, okay, it's going to be like this, 1 year down the line, it's going to be like, no promises. You show me a working code and I'll decide whether you are on track or not. So the service people, the company which is giving the service, like let's say Cognizant, Infosys, TCS, that team gives a demo to the customer periodically, and then the customer decides whether you are on track or not. Whatever you developed is correct or not, it's the customer who decides, and you take these regular feedbacks, let's say once every fortnight, something like that. And that's why, due to this continuous feedback from the customer, you are always on track. If the customer wanted an elephant and you started making something like a buffalo, the customer is going to stop you then and there itself, and it's going to say, see, this guy has a horn and I don't want horns. Elephant doesn't have horns. How did you develop the horns? So stop doing that. You're doing something wrong. So you fail first. You don't fail at the end. You fail first. Let us say in a fortnight, if whatever you developed, the customer is going to say, what are you doing? This is absolutely wrong. This is not the right kind of project. This is not right kind of product. So you get that feedback immediately and you course correct yourself immediately. Okay, and that leads to a lot of, you save a lot of resources over there. Otherwise, you would be on the wrong direction. You would keep working in that wrong direction for an entire year, and at the end the customer is going to say, that's not the product I wanted. Don't do that. Okay, you should give an early feedback. It's good for both the parties, and it also leads to it also avoids the contract negotiation at the end, and it saves both the parties all this hassle, all this trouble at the end. Okay, then point number 3, you always talk about a working product. Like for example, you don't say that, you don't talk in terms of words. You show a working product. You don't say that, I made a database layer this time, and see, these are all the columns. These are all the tables. These are the columns. These are the relationships between the tables. The customer is going to say, you talk in plain English to me. You show me a product. You show me something that is working. I don't understand that technical XYZ. Okay, that's the language the customer is going to use, and you get the message loud and clear that, don't talk technical, talk in plain English, talk in the business terms. And that's why you will in the first so-called sprint means an iteration means okay, I'll come to that. So sprint means the duration between every demo that you give to the customer. So as I said, every fortnight you're going to give a demo to the customer. So that fortnight, those 15 days are called as sprint. Okay, and in that sprint, before you start the sprint, there's called as sprint planning meeting. So you plan what you're going to do in that particular sprint. Then every single day of the sprint, you're going to have a daily stand-up meeting, that is DSM, wherein the team will see what is the plan for today. Okay, so in the initially you have a sprint planning meeting wherein you decided for a fortnight what I'm going to do for this fortnight, means what I'm going to do for this sprint. Every single day you're going to have a DSU, that is a DSM in Basic Agile, it is called daily stand-up meeting. In that meeting, you're going to say whether you're on track for achieving that sprint goal, what you did yesterday, what are you going to do today, and is there any impediment. Okay, so you're going to plan for the day in the DSM meeting, that is daily stand-up meeting. Then once or twice in the sprint, there's a meeting called as estimation meeting. Now in that estimation meeting, you're going to estimate the stories for the next sprint. Okay, that means you're going to see what kind of things you want in the next sprint, what will you be implementing in the next sprint. So you're thinking ahead of time. Okay, that is one thing. At the end of the sprint, you're going to show a working product to the customer. You will be giving a demo to the customer on a working product. You will seek his feedback. He will approve or reject your stories, and then there'll be a sprint retrospective meeting as well. That means you will retrospect how this one fortnight went, what went well, what didn't go well, what can be done better the next time. So you're retrospecting yourself every fortnight. So first thing, you're getting a feedback from the customer. So if you're going wrong as per the customer is going to stop you then and there itself. Next thing, you're getting a feedback from your own team. So if the team thinks, let us say the Scrum Master is too strict, or the product owner is too, bossy, and the product owner wants you or, forces you to take a couple of stories and get them delivered ASAP, he doesn't listen to anyone, then that feedback can also be taken in the retrospective meeting. Then let us say the people feel that the working environment is not well, it is not sustainable. We have to work late night, late shift, it's not going to work. For one sprint it's okay, we can give a nice productivity, but in the next sprint maybe we'll collapse, this is not going to work for me. So that kind of feedback can also be taken from the team. Okay, so you're getting feedback from the customer during the demo meeting. In the retrospective meeting, you're getting the feedback from the team. And that is why you will never fail, because you'll course correct yourself, you'll take actions as per both these feedbacks, you'll be taking action, you'll be course correcting. Even if you're going in the wrong direction, within a fortnight, you'll come back on the right track. And that is why this agile environment is better than the waterfall model, because you get continuous feedback and you continuously course correct yourself. You have a better life over here. The next stage is, of course, in this basic agile, there are 4 values. You can go through them, or you can refer to my earlier video upon it. And these are the 12 principles in agile. You can also go through them or refer to this video. Now friends, if you really want to know something in detail about basic agile, then I'll highly recommend this playlist to you. I had created this playlist long time ago in I think January of 2019, so it is that old. Of course, it belongs to an era where SAFe was not in the market, and people just used to talk about waterfall versus agile. So I have explained every little nitty-gritty about basic agile over here. A couple of topics are still left, like what is MVP, that is minimum viable product. This kind of topics are left. I will be adding it in the same playlist in the future, in the coming future, means let's say in a month or two. So please go through this particular playlist. You will get the entire idea about basic agile. I will just run you through the topics. The first video is about how to kickstart your project. So I've talked about how you take the requirement from the customer. Like if you have to make a product backlog, then what is the way in which you write your stories? Like as a customer, I should be doing this so that that happens. Okay, so that format, it is explained over here. In the second video, I have explained it to you in detail what is the difference between waterfall and agile. So, you're seeing the same thing in this video itself, so you can very well skip this video if you want. The third video talks about what you do in sprints 1, 2 and 3. So in sprint 1, of course the stories are not ready for with you. So what will you develop? You won't be able to develop anything, you won't be able to test anything. So your testers and developers only set up their machine. And the BA people, they actually make the product backlog. They start making the product backlog. Product backlog maintenance is a continuous process. So at least from sprint 1, they start making the product backlog. In sprint 2, the estimation of those stories happens. So they explain it to the development team and the QA team, and the developers and QAs estimate those stories. Okay. Also, this is the time during which the architect can take a good opportunity to set up the architecture of the project. Like for example, how the database should be. So, making the database and that kind of things. Now, in the third sprint, you actually start executing those stories. That means you start developing those particular stories which you had estimated in sprint number 2. So this is what you do in the first 3 sprints. That is very critical because I'm assuming that the people watching my videos are Scrum Masters and above. So if you are into management, you should at least know how to kickstart a project. That is very, very essential for you to know. You cannot go in an interview blank, okay? And it would be great if you have an experience about starting a new project. If you don't have, then at least read this, see this video, you'll get an idea. And you should wait for an opportunity when you are able to kickstart a new project and bring it into development and all. It's a very great opportunity. You seek that opportunity if you get in the future. Point number 4 is about poker card estimation technique. So this is a standard technique that all the agile projects follow while estimating their stories. So what is it? How is it followed? What are the nitty-gritties of that poker card estimation technique? Why do we follow it this way? Why Fibonacci series? All these questions will be answered here. Then improving estimates in every sprint. See, this is the crux of agile. Every single sprint you estimate the stories coming into the next sprint. Okay, so these estimations keep improving over the time because you get more and more stories in your reference. That if this is a story, then it is a 2-pointer, you know it now. If that is a story, then it is like 5-pointer, you know it. So more and more references come into your mind, and then when you estimate maybe say 100 sprints ahead, so in the 100th sprint you'll have the experience of your 99 sprints, and that's why your estimation will be more and more realistic. But still, you should purposely very consciously try to improve your estimates. You should try to reduce the delta between the estimated time and the actual time required to execute that particular story. So how to do that, it will be explained in this particular video. This is not a very important video. I have just I've just told you what are the basic durations of every meeting in Agile, because people often get confused, and I even saw a couple of interview questions on this little topic, that how long your meeting should be. So I said, okay, if I missed that topic, I made a video on that. So this is the duration of all the meetings, and I've also given a couple of tips to keep your meeting durations as short as possible. So how can you reduce the duration of your meetings? You'll get the tips over there. In the second last video, you are going to see the tips to reduce the bug count. Yeah, that is very, very critical. In Agile, basically you are just running. It is sprint, so you just keep running. So the development time is very less, but within this time, if you are developing in a great speed, then you should also be developing with least defects. That means your quality should also be good. And how do you maintain that? I'll give you some tips. Like, for example, the tip given in this particular video is like you should arrange some reverse KT kind of a culture. That means before a developer starts working on a story, he should be giving a reverse KT to the business analyst and your QA, so that if there's any gap in the communication, it gets cleared before he starts the story. And many such tips will be given in this particular video. Please see that. It's a good to have video. It's not very important for the interview, but still in real life it will be of great advantage to you. And the last video is about various deployment environments. So deployment environments like development environment, QA environment, staging environment, production environment. Development environment is for the developers, so that they can test their own code, okay, so that they can change the records without impacting the QA. QA environment is the environment in which the QA builds are given, so QA actually tests on that particular environment, okay. And staging environment is the environment in which the product owner can test the functionality, so that the product owner does not have to rely upon the QA environment to be free for him to try and test his things. No, he can do his own experiment on the staging environment. So QA and product owner can be completely independent of each other. And the final environment is like production environment. That is the environment in which the final users are going to use that product. That means it is the actual environment, it's the actual deployment that your actual customers are going to use. So your production environment should always be live. It should never come down. You should have a continuous integration, continuous deployment cycle. That means CI/CD pipeline should be there. So glimpse of it will be explained over here. I have probably not discussed about CI/CD because I don't know why I didn't discuss. I should have discussed it over here, but probably I did not. But you'll get an idea of how many environments are there, and these are at least these 4 environments must be there in your project. Okay. Besides this, also a couple of videos I'll be adding to this playlist, like what is an MVP, that is a minimum viable product. That means in the first sprint, whatever you deliver, that is a working product, and it should be a minimum functionality upon which the product owner can give some suggestions for improvement, and that is called as a minimum viable product. Then I think there should be a couple of more videos also. So as and when I think about topics, they will keep adding to this playlist. So keep this playlist bookmarked somewhere, and it may have some additional videos in the future. Okay, now let's go ahead to SAFe. Okay, now going ahead, what is SAFe? In SAFe or Scaled Agile Framework, there E doesn't stand for anything. It is just a marketing gimmick. It actually, SAFe stands for Scaled Agile Framework. That small e is added because it is not an acronym. That is why it is small, and it does not mean anything. They didn't want to call it SAF, and they wanted to call it SAFe, and that's the reason why they added that additional e. Otherwise, that e doesn't stand for anything. Okay. Now, what is Scaled Agile Framework? In Scaled Agile Framework, what we say is, instead of one team working, if we have many teams working in parallel on the same product, then that is called as SAFe. Okay, so more about SAFe in the next lectures, because this entire session is all about SAFe. So you get the basic idea: waterfall, basic agile, and if many agile teams are working together, then it is called as SAFe. Okay, if you have any doubts, feel free to comment, and also my contact details, my mobile number, my home address is given in the video description. Please feel free to reach out to me. Until next time, Jai Shri Krishna to all of you.